Hello dear students of class 1, medical, non-medical and respected teachers. In this video I am going to discuss about work done during an isothermal process. What is isothermal process? It is that process in which change in pressure and volume takes place but temperature is kept constant. So suppose we have a cylinder having perfectly conducting walls and a perfectly conducting frictionless piston. Why perfectly conducting? Because heat can flow from gas into the surrounding or from surrounding into the gas. Containing 1 mole of an ideal gas at initial pressure P1, volume V1, temperature T1 Kelvin. Now when gas is allowed to expand by giving some heat to the system or it is compressed, work has to be done. And to find work done in this isothermal process, we use first law of thermodynamics. The first law of thermodynamics states that dQ is equal to du plus dW, where dQ is the amount of heat added or subtracted. du increase or decrease in internal energy of the system. dW amount of work done by the system or upon the system. Now since temperature is kept constant during an isothermal process, suppose that this gas is allowed to expand slowly, volume of the gas increases, but as its temperature will tend to decrease. But as it is in thermal contact with the surroundings, so heat flows from surrounding into the gas, so the temperature is kept constant. When gas is compressed slowly, volume of the gas decreases and temperature tends to increase. But as it is in thermal contact with the surrounding, so heat flows from the gas into the surrounding because of perfectly conducting walls. So temperature is again kept constant. So during both isothermal expansion or isothermal compression, temperature is always kept constant. So as temperature is constant, so du is equal to 0. There is no increase or decrease in internal energy of system. So therefore dQ is equal to dW. That is amount of heat supplied is converted into work done is equal to PdV. By definition, work done pressure into change in volume, because volume changes at given pressure. Now W total work done, if volume changes from V1 initial volume to V2, then W is equal to integral V1 to V2 PdV. Total work done is given by integration of PdV from volume V1 to V2. Also, if we consider a geometrical diagram known as PV diagram or indicator diagram between pressure and volume for this isothermal process, we get this isothermal AB from initial position P1 V1 to P2 V2. So work done geometrically will be equal to area under this isothermal AB. So therefore W is equal to integral V1 to P2 PdV, or work done is equal to area under the isothermal AB, that this shaded portion of the graph is equal to amount of work done during isothermal process. Now for ideal gas, PV is equal to RT. This is ideal gas equation. P is pressure, V volume, R gas constant, T is temperature. So from this we can find value of P is equal to RT upon V. So W is equal to integral V1 to V2, substitute value of P, RT upon V into dV. Now since R is constant, temperature is kept constant. So W is given by RT integral V1 to V2 dV upon V. So by definition of this integral, dx upon x is called log x. So it means this integral v1 to v2 dv upon v will be log v to the base e. So w is equal to RT log v to the base e, limits v1 to v2. Substitute upper limit first, then lower limit. So we have RT is equal to log v2 minus log v1 to the base e, or w is equal to RT log v2 upon v1 to the base e, because log m minus log n is equal to log m upon n. And if we convert this log, natural log, into log to the base 10, so we get w is equal to 2.303 RT log v2 upon v1 to the base 10, so which is required expression for work done during an isothermal process. So this is the expression for work done during an isothermal process. Till next video, stay tuned. I will post all the videos for 9th, 10th, 11th, 12th class very soon. So keep in touch. All the best. Be happy. Good luck.